Alright, we're going to continue on with the algebra exam review, and we're on problem number 48, the word problems. The first step is to read it, define your variables, write your equations, solve, and then answer the question. This is a perimeter of a rectangle, so my suggestion is you draw yourself a rectangle. The length of a rectangle is twice as long as its width. Well, I'm going to say the width is W. Well, if the width is W, then the length would be twice as long, or 2 times W. Okay, now I've defined all of my sides, which are my variables in this case, and I want to, for perimeter, that means to add up those lengths. So when I combine like terms, I get 1 plus 2 plus 1 plus 2 gives me 6W equals the perimeter 24. Divide by 6. And the width is 4 inches. Well, if the width is 4 inches, then what's the length? Well, 2 times 4 would be 8 inches. So when you write it in terms of dimensions, it's usually length by width. So it would be 8 by 4 inches or 4 by 8 inches. It doesn't matter. There would be the perimeter problem. Okay, consecutive integers. You have 3 possibilities here. You could have consecutive integers, consecutive even integers, or consecutive odd. In this case, we want to sum 3 integers, so I need to define all 3 of them. The first integer is always x. It's the second and any additional ones that might be different. In this case, consecutive integer means one right after the other, so in order to get from the first to the next, we would simply add 1. So when I define my 3 integers, it would be x, x plus 1, and x plus 2. And it says the sum of them, so when I collect like terms, I get 3x plus 3 equals 1251. And now I solve that. So I will subtract 3, and then divide by 3, and the first integer is 416. To find the other numbers, which is what the question said to do, I would add 1 and add 2. So the integers are 416, 417, and 418. And a quick check would be that they are indeed integers that come one right after the other, and that if you add them you get 1251. Okay, the other type of word problem you might have is what we call a number problem. That's just where you're going to say the variable x represents a number, and you just translate this equation and solve. Half a number means 1/2 times x. Increased by means plus. 30 means equals 25. There's your equation to solve. Now it's just a matter of solving it. So we want to get rid of the 30, so subtract 30 from both sides. And now what gets rid of the 1/2 is if you multiply both sides by the reciprocal of 1/2, which is 2 over 1, or 2. Here those cancel to just give you x, and negative 5 times 2 is negative 10. So the number is negative 10. Okay, the last part of the algebra chapter is all about those equations and solutions and graphing and so forth. So to find 3 solutions, what that really means is 3 points on the line. To find the points, we solve this equation for y, and the steps for solving for y is always the same. Get rid of the x, divide by the number in front of the y. So to get rid of this x, I would subtract 5x. That leaves me 3y equals negative 30 minus 5x. Divide everything by 3. If it divides evenly like it does here, write the number down. If it doesn't, leave it in fraction form. There's your equation solved for y, ready to now find 3 points. If you have a graphing calculator, you can now plug this in y equals, and then go to the table. That would be second graph. And then you would find any 3 points on the line. If you don't have a graphing calculator, you substitute in any values you want for x and calculate the values for y. Typically, I use the values of 0, 1, and 2 for x, and then I find out the equivalent y's by plugging that in. So I'm going to plug in 0 for the first value. And you always follow the order of operations, so multiply first, then add. So when you do that, you get negative 10. So one solution or point is 0, negative 10. Now plug in 1. And when you do that, you get a decimal, which since we're going to graph, you can go ahead and leave it in decimal form. Negative 11.6 repeating, or negative 11.7 if you round. Plug in 2, and you get negative 13.3 repeating, or negative 13.3. And these would be 3 solutions. They're not the only solutions to that equation. They're just 3. You can plug in any value for x and get any value for y, and that would still be a perfectly valid answer. Okay, let's do number 52. First step, solve it for y. So we have to subtract the 8x. Bring down the negative y equals negative 24 minus 8x. That's really a negative 1 in front of that y, so you have to divide everything by negative 1. So that gives you negative divided by a negative is positive 24. Negative divided by a negative is positive 8x. And since I'm not graphing here, I can plug in any value, so I'm going to use the standards 0, 1, and 2. When I plug in 0, I get 24 plus 8 times 0. Well, that's just 24. Plug in 1. 24 plus 8 times 1. Well, that's just 32. And finally, 24 plus 8 times 2. And that's going to give you 40. Now, if we were actually graphing, this would be, you would end up having to change your scale because my graphs that I'm going to give you on the exam aren't going to go up to 40. They're only going to go from negative 10 to positive 10. So you might have to count by 4s or 5s or something. Hopefully that won't happen. Okay, let's try a graphing problem. You start the same way, meaning you begin by solving for y. So I'm going to subtract 3x, bring down the negative y, because negative 18 minus 3x, divide by negative 1, and you get y equals positive 18 plus 3x. I want to find 3 points. I'm not going to show that work, but it is on the exam review key, written key. Here are some points: 0, 18, 121, 224, that if you were doing it by hand you might select. If you had a graphing calculator, you might choose points that were within the negative 10 to 10, and that would be negative 5, 3, negative 4, 6, negative 6, 0 would be some options. They're not the only ones. If you choose these points, you would then need to change your scale. Maybe, count a little bit. Instead of counting by 1s, count by 2s. But I'm going to use these points. So negative 5 is left 5, up 3. Negative 4 is left 4, up 6. And negative 6, 0 is left 6, up none. Connect the dots, put arrows on the ends, and that line would look the same as your line if you used these other points and changed your scale.